Welcome to the second video in Unit 4. This is 4.2 Polar Conversions. Listed on this screen are the toolkit that we talked about in the last video. Be sure you have this written down. And the objectives for this video. We're going to review the toolkit, which is what we're doing right now, convert points from polar to rectangular and vice versa, and convert equations back and forth from rectangular to polar. The first thing we're going to do is convert rectangular functions to polar functions. And the main word for this, or the easiest way to do any of this, is to use our toolkit and perform substitution. When we have things with rectangular coordinates, rectangular is going to have x and y in them. And polar functions are going to have r, theta, or even trig functions like tangent of theta or sine or cosine. So that's what we're doing. So you can see right now we have the equation. Our first example is the equation of a circle centered at 0, 0 with a radius of 2. And we're going to convert that to a polar equation or a polar function. So we see right here that we have an x squared plus y squared. And if we go to our toolkit, we also have an x squared plus y squared. So that means we can substitute r squared for x squared plus y squared. We can take the square root of both sides so that we get r equals. And remember that when you take the square root of something squared, it's plus or minus. But what this is an equation of a circle, right? With a radius centered at 0, 0, right? Doesn't go right or left, up or down, but then the radius is 2. So you're going to go out 2 in all directions. So it's going to be a circle, right? So you don't need the plus or minus. What I'm trying to say is the radius is always 2. So we're rejecting negative because the radius can't be negative. So most times on here when we take the square root of something squared, we're just going to take the positive because the negative is either doesn't work or it is included in the positive. Okay, we're going to use the same toolkit to do this equation. Right? You can see the x squared plus y squared, so doesn't it make sense that you're going to replace x squared plus y squared with r squared? Okay, and then we see here we have y over x is equal to tangent theta, so we're going to replace the y's and the x's with tangent theta, and that is a quantity squared, and then we take the square root of both sides. So we have r equals, and once again, you're going to have plus or minus, but we're going to reject the negative, so it'll be 3 tangent theta. Okay, and that is your answer. So you've converted a rectangular equation into nothing but using polar equations. This is the equation of a line, and so we're going to convert this line equation, rectangular equation, into a polar equation of a line. It's still going to be a line with a slope of 2 and a y-intercept of -3. But we can see here that we have a y, and we have a y here, so we can replace a y with r sine theta. Likewise, wherever there's an x, we're going to replace that with r cosine theta. We need to get it so that it is r by itself. So what I'm going to do is go ahead and multiply this 2 times r and then subtract it to the other side. So I have r sine theta minus 2r cosine theta equals -3. I'm going to factor out an r from both of these terms. And then I'm going to divide both sides by this part that I've underlined here so that r will equal -3 over sine theta minus 2 cosine theta. And that is the equation of a line in polar coordinates. if we can convert from rectangular to polar, we can certainly do the opposite. So you can see the r and the theta here in this polar equation. And so we're going to convert that from polar to rectangular. So what we want to do is we're going to leave the r in here for a second, but we are going to replace sine theta, okay, with, and I've got it worked out here, but if I put it back, remember sine theta is y over r. So I'm going to leave the r, but I'm going to replace sine theta with y over r. Okay. Now I want to multiply both sides by r, because I have an r in the denominator. So I'm going to multiply both sides by r, and I get r squared is equal to 4y. Okay, and I'm really close. I need to replace the r squared. Well, r squared is equal to x squared plus y squared. And if I subtract, and complete the square, I have a circle centered at 0, 2, with a radius of 2. And so you can see that that is a circle written in polar coordinates. Okay, one final example. We have theta is equal to 2 pi over 3 radians. And so what I want to do is I want to convert this to from polar to rectangular coordinates. So I have theta. If this is theta, then I can take the tangent of theta and make it equal to the tangent of 2 pi over 3. The tangent of theta is equal to negative square root of 3, because it's in the second quadrant, where tangent is negative. And then we know that tangent is equal to y over x. And then if I multiply both sides by x, I have the linear equation with the slope of negative square root of 3 times x. So you can see that this is a line, a linear written in polar. This is polar. And this is a line written in rectangular. Okay, I'd like you to work these two problems in your notebook, number 43 and number 61. I'd like you to do number 43 as a circle, and I would like you to convert it to a polar equation. And 61 is already in polar, and I want you to convert it to a rectangular equation. And you should have these in your notes, and we will check these when you return to class. See you then.